Hi guys, and welcome back to another lesson in Algebra 1. Today's lesson is Unit 1, Lesson 7. We are continuing our study of equations, and we're going to specifically talk about literal equations today. So this is day 2 of literal equations. Now remember, literal equations are one of those kind of weird looking equations that has several different letters in it or variables. So our objectives are I can isolate one of those variables in a literal equation. You can use the inverse operations. And then this is actually a pretty useful skill for science and engineering problems. The idea of being able to manipulate equations and be comfortable with several variables, it actually does come up quite a lot in chemistry and in physics. So this is a skill that is helpful to master. Alrighty, let's go ahead and look at what's going on here. So the notes are just going to be kind of a rehash of what we talked about last class. So to solve literal equations, alrighty, so what we're going to do is we're going to use inverse operations to isolate the variable. So remember, they're like Twinkies. They kind of go together. Each operation undoes the other. So we have addition and subtraction. Those are Twinkies that go together. Addition undoes. Subtraction and subtraction will undo addition. And multiplication and division are Twinkies. They belong together. And I do want to go ahead and add another little tidbit here. We can square something. Whoops, I don't know why I wrote that square there. Let's see. We'll erase that part. Yeah. Okay. So another example, we can square something. And then the inverse would be to take the square root. Okay. So we need to realize that those are, one of the pairs that go together. So let's look at the next thing. It says, tip, you can list out operations that are around your variable if you want to isolate. And then you work the problem backwards to undo these steps. So let's give this a try. Let's try writing this stuff out. Okay, so this one is asking us to solve for x. And our x is located right here. Okay, so we're going to look at the first thing that's closest to x, which is a. And so, x is multiplied by a. Okay, and then, then we have by. And so by is added to ax. So what we can do is we can take this and we can reverse it. So we are going to start from the bottom and go to the top because we are going to do reverse PEMDAS. Okay, so we're going to reverse the order of operations. So what does that look like? If we say that by is added to ax, then the inverse would be subtraction, right? That would be the complement to that. So I'm going to write my equation over here again, and let's get it all nice and organized here. And so if by is added to ax, the inverse is we're going to subtract by. Okay, so we get ax equals c minus by. All righty. Well, okay, so we have done this one. let's go up to the next one. Okay, it says x is multiplied by a. So a is touching x. The inverse operation of that would be divided, right? X is divided by a, so we can divide by a and divide by a on both sides. And we get this where it says x equals c minus by divided by a. Okay. We solved it like it was a two-step equation, but the problem was is that it was a bunch of letters. So we didn't have like numbers that were simplifying. We had to just, kind of adapt and overcome on our own. So you can see how, writing it out, like what's happening to the variable and then going in reverse and doing the inverse can help if that's a strategy that may help you. Okay, so let's look at this one. It says f equals 12k divided by a, and we want to solve for k. So I am just going to take a moment and I'm going to highlight the variable that we're interested in. So we want to solve for k. So we want to get that by itself. I am just going to go ahead and list out what is happening here. So closest to k, we have um, k is multiplied by 12. And then the next closest thing is that 12k is divided by a. Okay, so we can see that that is, just kind of listing out what's happening. 12 is touching k, which means multiply. And then a is at the bottom of the fraction bar, so that means it's being divided by. Alrighty. So our first step is we're gonna reverse this. We're gonna reverse PEMDAS this. So it says 12k is divided by a. The inverse operation is going to be multiply, right? So multiply goes with divided. So if we write this over again, we got f equals 12k divided by a. So instead of doing this divided by a, we're going to go ahead and multiply by a, which is just what I said over here. And so we took that divided, we're going to replace that with multiplied by a. All right. So the a is going to cancel out, and we get a times f equals 12k. And so our next reverse step here was k is multiplied by 12. Well, the inverse operation for that is going to be divided, right? Okay, so 12 times k, we're going to divide by 12, divide by 12, 12 cancels, and we get af divided by 12 equals k. Okay, so what was our first step here? It says, what is the first step? I can just go ahead and fill this in. First step, we're going to multiply, multiply by a. Alrighty, so this one we got a equals 3b plus 4h, and we're going to solve for h. Alrighty, I am just going to make this as concrete as I can. We're solving for h. My h is right here in this position. So we've got to get everything else moved away from it. So let me just kind of take a little side note over here. And what is close to this h? So the first thing that I can see that's closest to h is multiplied by 4. Okay. And then I can see the next closest thing to it is here where it's 3b is added to 4h. Okay. So that was the layers moving away from H. I started closest to H and then went further. But to undo that, to do the inverse functions, we've got to back that back up. We've got to reverse it. Okay. So if I write all of this out over here, we got A equals 3B plus 4H. I am going to do the reverse of what's here. It says 3B is added to 4H. So I am going to subtract it. I'm going to subtract 3B, subtract 3B. Let's see, that cancels. We get 4H equals A minus 3B. And so we've done that reverse. And then this one, it says H is multiplied by 4. Well, we see 4 is touching H. So we're going to undo that multiplication and we're going to divide by 4. And so we get A minus 3B divided by 4 equals H. And so what was our first step? Our first step when we looked at this is we had to subtract 3B. Alrighty, so we got this guy here, px plus qy equals r, and it says to solve for y. So I am going to go highlight this real fast. My y is right here. So I need to get that by itself. So what are the layers that I need to do that? And so what I'm going to do is I'm just going to list what's close to my y. So the closest thing is y is multiplied by q. And then the next closest thing is this px over here. And so then we can say px is added to qy. So we know when we are peeling these layers away, we got to reverse PEMDAS this. So if I go write this again, I've got px plus qy equals r. And px is added to that, and we know that the inverse function to that is subtract. So to do that, we are going to simply subtract px. Because px is added to qy, the inverse of that is to subtract. So that cancels. We get qy equals r minus px. And the next one, it says y was multiplied by q. And so the inverse function of multiplied is going to be divide. So we're going to divide by q. That cancels, and we get y equals r minus px divided by q. And so the question asked, it said, what is the first step? Well, the first step is going to be to, let's see, first step, we're going to subtract px. Okay, that would be our first step. Okay, this one is a nice, easy equation where we're going to solve for m, p equals mb. And so if I write this over again, I got p equals mb. And they want us to solve for m. So m's right there in the position. So there's only one thing to do, which makes it nice and easy for us. P or m is multiplied by v. So to undo that, our first step is going to be to divide by v. Okay, so we're going to divide by v, and we get p divided by v equals m. Okay, we have this. This is our Pythagorean theorem, right? A squared plus b squared equals c squared, and we need to solve for b. So what is the first step? Well, let's highlight where b is. So we're solving for b right here. And so we can see our first step. If we've got a squared plus b squared equals c squared, our first step to get that b more isolated is we're going to subtract a squared. Okay, so we can subtract a squared, and we get b squared equals c squared minus a squared. Okay, now we do have a square on that b, so we've got to undo that. So the inverse of that is going to be to take the square root. And we're going to take the square root of both sides. Now, technically, when you do this, you get b equals plus or minus c squared minus a squared. Okay, why is it plus or minus? Well, let me give you a little side example over here. If we say we need to make 9, we have two ways that we can make 9. We can do 3 times 3, which would be the positive version, but we can also do -3 times -3, and that would give us 9. So I'm not so worried about if you're writing plus or minus there, on that at this point in this game. But you do need to feel comfortable taking the square root. Alrighty, let's look at example 6. We have this volume equation, so pi r squared h, and we need to solve for r. Well, our r is right here, and we see there's a square root touching it. If we even listed out the things that were by r, we can see the things that are by it. We have 1, r is squared, and the next square is r squared is multiplied by pi and h. Okay, so we can reverse this. So if this is multiplied by pi and h, we can divide by those. Okay, so let's do that. Let's write this out. We've got volume equals pi r squared h. We can divide by pi and h. We can divide by them at the same time, which is kind of handy when we're dealing with the variables like this. Okay. So pi and h are going to cancel out, and we get b equals pi h equals r squared. Now, the r is squared. Okay, we said that right here. So the inverse of that is we're going to have to do a square root, right, to undo that. which means we're going to have to do a square root here, and we're going to have to do a square root here. So we're going to get the square root of v divided by pi equals r. And technically, we can put a plus or minus for the same reason that I showed you on the previous one, where, technically when you multiply something like -2 times -2, that gives you +4, but a 2 times 2 gives you a +4 too. I'm not super hung up if you're writing the plus or minus right here with this. I'm just including it just because, but don't get super hung up if your brain doesn't remember that. Anyway, hope that helps, guys. Until next time, bye.